Hello, everyone. I'm excited to talk about how to make our own functions in R today. What we're going to start with is understanding what actually goes into a function. On this slide, we have all these different pieces, and each one is important when we're thinking about making our own function inside of R. First thing is a name. If we give it a name, that means we can use it over and over again. We just call in the name and it'll come and do its work for us. In this one, we're just calling it doit. It can be good to name functions verbs of some sort because functions are doing things, but it's not required. You could call it anything like Jimmy or Susan. That's just fine. And then the assignment. Note that the assignment looks like an arrow in my case because I use a special font that does that, but really it's just like caret and the dash. One of the most important pieces of creating your own function is actually the function. It is the function called function. What we do is we write function, and then we have parentheses, and inside of those parentheses is going to be the stuff that the function needs to know to run. We're going to tell it these are the things that it needs to know. And then on the outside of those parentheses, you have a curly bracket, an open one, and then at the end of the function is a closed one. Everything in between the two curly brackets is what the function's actually going to do. So you can see all these pieces. We get a name, we use the function. We'll have some stuff possibly inside of the parentheses, and then an open and closed curly bracket with code in between. And that's it. And then a function's going to do whatever you tell it to. So consider this example. We're going to call it to2, and we use the function. And this time, we're not putting anything in the parentheses, so we're not requesting any information for this function to actually run. And then we have an open curly bracket and a closed one, and in between those, we have 2 plus 2. So if you think about what this function is going to do, it's not asking for anything from us, it's just always going to run 2 plus 2. That means 2 is always going to just return 4. That's it. It won't do anything else. It's not that amazing of a function, but it is a function. So if we run it, it's going to give us 4 every time. And we're going to show that later on. Consider another example. This one's add2. This one we're asking for one thing. We're calling it num. So often what people will do is write the name of the object that they're asking for to give hints of what kind of thing that they're wanting. In this case, we just want a number. And we'll be able to see that when we look at the code. So we're just saying num, and then open and close curly brackets, and then we have num plus 2. This one will take the number, whatever number we give it, it will put it in the place of num, and it will add 2 to it. So we could put any number in place of num, and it's going to put it in there. I'm going to show that one too in just a moment. So we pull up our studio. And in our studio, I have our little doit function. This one we're just going to leave empty. It's just going to remind us of the pieces that go into a function. So first thing, let's create the to2 function. We just did to2, and then function. And we don't request any information, so we just leave that blank. And then I'm going to do the curly brackets. It gives me 2 automatically. I'm just going to press enter. And then for this function, we just did 2 plus 2. So if I am on here and I run this code right here, in the corner, in the environment, we now have tutu as a function. I'll move this over so we can see it better. It's just a function, and it has some code in it, and we always can see what that code is by just clicking on this. And this pops up, and it tells us exactly what's in that function. So if we go back to this, we can see what happens when we use that function. So it's just tutu, and anytime we're using a function, we just put the parentheses after it. And if I just run that, it gives me a 4. And that's all it's going to do. And if I try to put something in here like a 9, now it's going to say unused argument. In other words, you told me that I don't need to ask for any arguments, so why are you giving me something? And so functions automatically will give an error, which is great. We can run this again just to make sure. Yep, still a 4. The reason why is it's always going to run that code. That's the code that we told it to do, and it's always going to be 2 plus 2. It's not going to change. So every time we run it, it's going to be a 4. Now let's try the add to function. This one we're just requesting num. And then in there we're saying num plus 2. We can run that, and now we have add to in the environment. And now if I try to just run add to without giving it any information, it's going to say, hey, the argument num is missing. You told me that I was supposed to get that, and you're not providing it for me. So what if we give it a number? Let's say 1. What do you think it's going to produce? What it's going to do is it's going to look for every place where num is, which in this code is just this one place, and it's going to replace that with whatever we gave it, in this case a 1. So it gives us a 3. It just put a 1 there and then did plus 2. What if we give it 10? Then it gives us a 12. What if we give it a word like thing? And it's going to say, wait a sec, that doesn't work. I'm trying to add 2 to something, and you told me to put thing everywhere where I see num. In other words, it's trying to put a word right here and then add 2 to it, and R doesn't know how to do that. What if we give it 2 times 2? Now it's going to run this first, and then it's going to add a 2 to it. Hopefully this is making some sense. A function just takes the code that you tell it and is going to run it. If we give it an argument, it's just going to replace anytime it sees that argument with whatever, when we actually go to run it, whatever we give it in that place, it's going to be there. All right, we're going to create a few of our own functions. First one, it's going to be called sentence num. And we're just going to ask for a number again. And this time I'm going to use the paste function. I'm going to create a sentence. The number you gave me was num. We run this, then to use sentence num, and let's give it the number 10. And now it just runs this, and paste function just glues words and other things together. And in this case, it just takes the words, and it takes the number I gave it, and it prints it out for me. Okay, for this next one, let's make one that does a little bit more with a little bit more information. So let's call it add together. And this one's going to take 2 numbers. We can call them num1 and num2. And let's just have them add together. So we can use this function. This time it wants two numbers. Let's do 10 and 8. Gives us 18. Hopefully this is making some sense. The pieces that a function's looking for and what we can do with it. What's cool is we can do any number of things inside the function. For one thing, maybe we're making a lot of the same plots over and over again. A perfect place to use a function in R is a place where you're running the same code over and over again. Instead of copying and pasting a bunch of lines of code, we can just copy just a function name by itself. It can really shorten things. I'm going to highlight that here. So let's say we want to keep making, put this down, I want to keep making the same plot. And the plot looks like, we'll just create some fake data real quick. In order to do this, I'm going to load tidyverse. We're going to create a new data frame or a tibble. And it looks like this. We have an X, Y, and then a grouping variable. And let's say we want to make a lot of plots that end up looking like this. And so when we do that, it's going to create a scatter plot with some smooth lines in there. Let's say we also want to use theme classic. We want to say group as a factor in this case. Okay. There's our not all that beautiful plot. Let's say we are exploring our data and we want to see this many, many times. Let me just add one more thing. I'm going to say method equals lm so the lines are straight. We want to do this many times. Well, we could copy and paste over and over again. And really quick, let's say we need to do it 4 times for a certain data set. It's already getting to be a lot of lines of code, and we can easily start to miss things. Even if we misspell something right there, we might not be able to see it. And let's say we accidentally put Y here instead of group. With so many lines of code, we're going to start to miss these things. So what we can do is we can start to use a function. So let's say we're going to call this scatter plot. And the function is going to take a data frame and let's bring this in. We can run this. Then we can do scatter plot and give it our data frame. And it's going to run for us. And so now if we needed to do 4 of these, we could do it in 4 lines. Another nice thing is if we find out, oh, there's something wrong with this code, we only have to change it in one place. Let's say we don't want the error bars, we can just say s equals false. We don't have to put it in 4 more places. You just have to put it in one, rerun the function, and then run this again, and it'll do it without the error bars. So a function, besides being really cool and allowing you to decide exactly what you're doing with your R code, what's really beneficial about it is it can simplify your code. It can take all of this and turn it into this. And as you get really comfortable with thinking this way, you're going to start to see a bunch of places where a function will help, and it's really going to simplify your code. It's going to help you understand how to avoid errors. It's going to make your code more readable. And so there's going to be a lot of nice things that come with it. Now note, when you make functions with the tidyverse, that includes mutate, filter, select, and all their friends. The tidyverse requires a very special way of using functions. It just requires that we use a few special characters, and then it's going to work just fine. There's also some ways that we can work around some of the complexities, and we'll talk about that as well. But note, if you're trying to use any of the tidyverse functions in there, it may get complicated. With ggplot, which is tidyverse, this one just assumed that your data frame has an X and a Y and a group variable. If those didn't exist, we would need to use these special ways of communicating with R that the tidyverse is going to allow us to do to make functions with those functions. Now note, the table1 function in furniture is just that. It's just a function that a colleague and I created. We started working on it because we needed it, and slowly we just built it out to do more stuff. So when it comes to a function, you don't have to just think off the top of your head, oh, this would be a perfect thing to add a function for. It's honestly something that just happens while you're working. As you're working, you realize, oh, this would be really nice to have. Maybe I can write a function for that. And if that's the case, it's a perfect place for a function. In general, a lot of people think, oh, it must just come, like all of a sudden you just have this like intuition and you create a nice new function. And that's usually not the case. It's very much iterative. You realize what you need in pieces. The table1 function has changed a ton since it first was created a long time ago. And that's okay. It's okay for it to change over time. And I will say, one way for you to learn how to create your own functions is by looking at other people's functions. I recommend going to GitHub and looking up packages that you like. For example, Janitor. You can look up Janitor GitHub on Google, and you can look at the functions that they have. We'll talk about this more later on in the class, but it's a great way to start to figure out what goes inside of a function. Another way that you can find out what's inside of a function is you can just type it out. One function that is nice, it's not too long, we can look at the washer function in furniture. So this is the whole function right here. So even though this function, there's a lot to it, right now this may feel really overwhelming. It's hard to understand what it's doing. And honestly, that is okay. I would have to go through this and refresh myself on what each piece is doing, even though I was the one that wrote it. The key is that all of this is just R code inside of this function. It's not entirely different than what you've done before. It uses a few new pieces, like if else and this for. It does all this stuff, but this is stuff that you can learn and you could pick up. In the end, you could be writing functions like this and functions that are a lot better than this. And when you do, it's going to save you a lot of time. Can you imagine copying this code every time I wanted to use washer instead of just this one line? It would take a long time, and everywhere where I saw X, I would have to replace it with whatever variable I was working with. And anywhere I see the dot dot dots, I would have to put the stuff I want in there. And so it could get really error prone. But instead, because we are able to create functions in R, we can just create a function and then just use the name of it. Because I wanted to hold on to the functions I created, I put them in a package. A package is just a group of functions. We're not going to talk about that in this class this semester about how to create a package. But there's a lot of great tools out there that help you create a package if you find that you have a lot of good functions that you use a lot. Putting it in a package can actually really help. So the last thing I want to mention is that even if you don't write your own functions, the reason why we went over that today is to understand how functions are written. All the functions you see in R are built of the same pieces. Some are a lot more complicated than others, but overall they're doing the same thing. They have a name, they use the function, they request information called arguments, and then they just have R code inside of them. Going forward, what we're going to do is we're going to look at loops. These are ways to do the same thing to many different things, like many different variables. Makes it so we could clean up a whole data set in a couple lines of code instead of needing 50 lines of code naming each variable and what we want to do to it. It'll help you save time and energy and make your code a lot more friendly to read. There's a couple ways we're going to be able to do this. There's some that are in what's called the per package. That's type that out for us. Per with 3 R's. We're going to be using a lot of that to help us work with data frames and cleaning them up quicker. I'm looking forward to it. Thank you.